If you've ever wanted to build an API and weren't sure how to go about doing that, then this video might just be for you. We'll be talking about FastAPI specifically, which is a library designed to make API creation easy and quick in Python. In fact, in this video, we'll be talking about how to create an API, how to do GET, create and post requests, and set up a DB all in 20 minutes. Of course, if you find this video helpful at any point, then consider leaving a like to let me know, and maybe subscribe if you want to see more videos like this. But before we get into the main topic, let me talk to you about authorization. If you've ever built authorization before, you know it can be a nightmare. OSO Cloud is a solution that allows you to quickly model centralized permissions and more fine-grained access control within your applications. If that sounds like a dream come true, then don't skip this. Creating authorization policies is easy using Polar, the open source declarative configuration language. And to get you started, you can use the built-in visual editor Workbench to build your policies from the ground up. From there, you can model, test, and integrate your rules into your application. The OSO Cloud service itself, which is built in Rust, securely stores all your authorization data for you. So all you have to do is make a few API calls. They provide clients in the programming languages you use every day, like Node.js, Python, and Go, as well as tools like the Visual Studio Code extension and their comprehensive documentation to make the entire process as slick as possible. To use OSO authorization in your Python application, all you need to do is pip install OSO Cloud like that, and then you just need to create a client using the OSO Cloud URL and provide an API key, which you can get from the desktop. I have it in my .env file over here. Just need to create a user and an organization, and then tell the client that your user has a particular role. So in this case, I'm saying that Bob has a role of owner in the organization. And from there, you can just call the authorize method on your client to check that a user, in this case, has the comment permission in your organization. If they do, you're good to go. Organizations like Intercom, Product Board, and PagerDuty are already using OSO Cloud for their authorization needs. And if you or the company you work for fancy joining them, you can sign up for free today by using the link in the description below. With all that out of the way, let's create your first API. To be absolutely clear, the duration in the title of the video refers to the amount of time I spent programming, not the overall length of the video, before anyone gets smart in the comments. But to install FastAPI, all you need to do is do pip install FastAPI. And this will install FastAPI, also install Pedantic, which I made a video about before if you want to learn how that works. FastAPI is very heavily reliant on Pedantic, and while I want to keep this as much like just FastAPI as possible, so we don't get distracted by SQL Alchemy, all that stuff, Pedantic is pretty vital, so we will be using that. And then we also need a way to run our API, and FastAPI doesn't provide a way to do that. And there are two things it recommends in the docs. The first one on the list was UVcorn, and I actually need to do quotes here because I'm on ZSH, and then just standard, we'll install the standard stuff. I already have everything installed, but you can see that FastAPI is actually built on Starlet, for those of you that have heard of that. And then we have Pedantic here as well. And I'm not actually sure what versions of things we have. So Pedantic 2.6.3, we have FastAPI 0.110.0, and then we have UVcorn 0.27.1. For all those that are curious. So I'm going to create a directory over here just called app, and inside this directory we need to create an init.py file. This app can be called whatever you want. I'd recommend you name that the name of your app rather than just app, but for the purposes of a tutorial we're just calling it app. This init can stay any, it just needs to be a package for everything to work. And then we create a file just called main.py, and this would be pretty much where all of our logic goes. In terms of this video anyway. So to actually create an API, you just need to do from FastAPI import FastAPI, app equals FastAPI, and then we're going to give it a title. So I'm going to call it just Carbra app, and you'll see what that does in a second. And then I'm going to give it a version as well. This defaults to 0.1.0. I'm going to do 1.0.0 just to be different. And then we can do app.get/. So this will be, a GET request against our index. And then once someone does that, we can run this function, and that's going to return a dict of string. And then we're going to return a dictionary saying message, hello world. And this is our API. We're done. I will be doing more advanced stuff, but I do want to show you that this works. So if I do UVcorn, what is it? Let me go in my history. There we go. App dot main, and then app reload. So this is the name of the module. So app is the name of the package, main is the name of the file, and then colon app is the name of the actual app itself. If you run that, we'll see that we get the server running on our local host. If we click that, it should, there we go. And then I'm going to have to zoom very far in. There we go, 400%, that should be fine, or maybe 500. There we go, we can always zoom out if we need to. See, we have message hello world, and we are just on 1.7.0.0.1, port 8000, and we have our thing here. If we go to raw data, then we can see that we have just a normal JSON object, which is cool. So we have an API that works. Now what to do with it? I'm going to create just a really simple fact API, and we're going to be doing some GET requests, some creates, and some deletes. We don't need to do an edit because Twitter lasted God knows how many years, almost 20 without an edit button. So quite frankly, we don't need one either. So first I want to model what a fact is going to look like. And for that, I'm going to come up to the top again and do from pedantic import base. Oh God, not that. Base model. And we're going to create a class called fact. We're going to inherit from base model. And then it's going to have an ID, which is an integer, a body, which is a string, and then we're actually just going to leave it at that. And this is what each fact is going to look like. So it will return a JSON object with just an ID and a body. And then when we actually get it to use it within FastAPI, it will be a pedantic model. So now is as good a time as any to create our database. So I'm going to come in here, and I'm going to create a new file called schema.sql. We are just going to use raw SQL today. You can use SQL Alchemy if you prefer, but again, as I said at the start, I don't really want to pollute this with other technologies that people just have to learn. So yeah, we're doing it like this. So create table if not exists. We'll need to give it a name. There we go, facts. And then we are going to have an ID, which is an integer and a primary key. And in SQLite, if you have an integer primary key, it will auto increment on its own, which is pretty cool. And then we're going to have body text not null, which basically means that facts have to have a body in order to be inserted. And then we'll leave that for now. And what we're going to do now is we're going to create something called a dependency, which will fetch a database connection when we require it. And this will make a little bit more sense once we actually start doing creating and getting. But for now, if we just do get db as a function, and that takes nothing, and then it returns an iterator of connection, and I need to do from typing import iterator, there we go, and from SQLite 3 import connection, like that. And we can do with, oh, I need to import SQLite 3, don't I? With SQLite 3.connect. And we're just going to have db.sqlite3. And we do actually need to do check same thread equals false. This is recommended in the FastAPI documentation. Basically what this means is that you can have multiple open connections at once and they don't conflict with one another. In reality, you'd probably want to have some sort of additional checking to make sure that things aren't going wrong. But at that point, you probably want to use Postgres, and we're getting way off topic again. So we're just going to leave it like that for now. And we're going to call that connection. And then we're going to do connection.execute script. And then we're going to have a script path. So we're going to do from pathlib import path. And we're going to define some constants up here. So we're going to have db path equals path db.sqlite3. Whoops. And then we're going to have script path equals path, and then app slash schema.sql. And this is basically just the path to our database and a path to our script. So I can actually replace this with db path now. db path. And then we just want to execute script path dot read text. Now, in its current state, this will execute the script every single time. For an example's sake, I'm going to say I'm not worrying about that. But you know, if you were to do something with SQL Alchemy, you'd do something a different way. Maybe I'll do a video on that at some point. But for now, again, don't want to pollute it, so we're just doing none of that. We do want to do connection.rowFactory equals SQLite3.row. And this will, instead of returning a list of tuples, what it will do is it will return effectively a list of dictionaries. It's not quite the same, but you access them in the same way. And that will be essential to what we're doing. And then we just want to do yield connection like that. So this is yielding the connection, and then once we're finished with the connection, it comes back into this function and it closes out this with statement here. And that's also why we're returning an iterator. This is how you would type hint anything to do with yielding. And this will be used to get our database whenever we need it. So now we can actually start creating things. So if I do app.post, and a post request is what creates things, I'm going to do /fact. And I'm going to set the status code equals 201. This is, generally the status code you would expect to see when you've successfully created something. And then we're going to set response model equals fact. And I'll show off what this is doing a little bit later, because this is doing something internally to help FastAPI. And we're going to do def create fact. And then we're going to take the body, which is a string. And this is treated as a request parameter. And then we're going to have DB, which is a connection. And then we're going to go up to the top actually and import something. So we're going to do from fast API import depends like that. And then we do connection equals depends get DB. Then we return fact. And I'm just going to pause here for a second while I explain what's going on. So our body is our, request parameter. When we send a request, we will need to provide a body, and that will be of type string, obviously. Our DB is set to our SQLite connection, and this depends is essentially a class, or I think it's a function, but it's rendered as a class in terms of its naming structure, which is a bit odd. And then we pass the callable in here, and what that does is it basically runs that function, gets the DB connection from here, and then assigns that to DB. It's sort of a little bit of, I guess it's dependency injection, but it's a little bit of magic that goes on. And this is why we call getDB a dependency, because we use depends to then call this function to assign to DB. And from here, we can simply just do db.execute, insert into facts, and then we just want to insert into body values, and we use a prepared statement. I did a video a long time ago on the basics of SQL. I don't know how relevant that still is or how good that video is. I'll link it in the cards, and we'll see if it's still any good, because that was a very old video of mine. And then we're just going to return a fact. So we're going to return a pedantic model, and then we're going to get execute, and then we're going to select the fact. So this is, I guess, optional, but I would say it was good practice. Order by ID, descending limits 1, dot fetch 1. There we go. If you're using something like SQL Alchemy, you'll probably avoid some race conditions, but this is basically just getting the last fact in the list, or the fact you just created, and then returning that back out to you. So if you then, it's already running. So if you come back over here, and if we go to /docs, this is really cool. You'll see that we actually get some cool little documentation. And from here, you can actually run things in the API. So we ran this and we got hello world back. If we create a fact, we click this try it out button here. We can put something in here. So Carbra started in 2019, which is an actual real fact. That's very true. Click execute. And we can see that we get our response body back. So we get a 201 code. We get ID equals 1, and then a body of a fact there. And if we go back over, we can see in the logs that, everything worked okay. But we don't have any way to actually get that fact yet. So we could do app.get /fact. So this would be now a get request to fact. And then we want to response model equals fact, like that. And if we do get fact ID, so again, this is another request parameter, and we do the same thing with our database. So I'm just going to copy and paste it. So I'm not typing it all out again. And this will return a fact much in the same way. And then we run facts equals db.execute select star from facts where ID equals that. And that'd be fact ID. Don't forget the trailing comma. And we do a fetch 1. And we actually want to do some error validation here. So before we do that, we want to come up and we want to import HTTP exception from FastAPI. Come back down here. If not fact, so if the fact doesn't exist, it won't error, it will just return none. So we can use this, so if something is none, then we raise HTTP exception, the status of 404, saying that the fact's not found. And that's all you really need to do. And then beyond that, you just need to return fact and unpack fact into it like that. And now if we refresh this page, close that, we can see we have this get fact in there now. And if we were to get fact number 1, we can see that we get the fact back. If we do fact number 2, or fact number 21, error not found, detail fact not found, and we have our 404 here. So before we move on, something I realized I've forgotten to do, but it actually still worked, which is really strange, was to do this. So we have /fact/ and then this represents the fact that there is a root parameter in here. So I guess at this point it's taken fact ID as a query parameter. If we wanted to do it as a root instead, then we pass fact ID into here. If we then do this, we can see that we have fact ID, and then the request actually looks slightly different. So if I were to do 1 there, we can see that it's now fact/1 instead of fact fact ID equals 1. So it depends what you want to do. If you don't provide roots in here, then these will be treated as query parameters. If you do provide roots in here, they'll be provided as root, and these names do need to match, otherwise it won't match up. So yeah, that was something I forgot to do, and it worked, and I wasn't expecting it to, but there you go. Final thing I want to do before we finish up is do some deleting. So we can do app.delete. It was fact/ and this is actually what prompted me, because my notes have fact ID in the get, but yeah, I just saw it in the delete and realized I hadn't done it. And then we want a status code equals 204. So this will be the same thing. We use fact/ and then the number rather than a query parameter. And if we do def delete fact, we pass fact ID as int again, and then we do our database. Is it the same? Yes, that's still on the paste buffer. Awesome. And then we were going to return none out of this. And you can actually do something fancy with raw SQL here that you can't do in SQL Alchemy, as far as I know. And that is by performing the deletion and then retroactively raising an error if it didn't work. So if you do row count equals db.execute delete from facts where, whoopsie daisies, where ID equals that, and then we pass fact ID here, and then .row count. This row count is the number of rows that were inserted, updated, or deleted from the database in this query. So selects, it will always be 0. Actually, I think it's always none. I forget if it's 0 or none. But essentially what this will do is if a fact was deleted from the database, this will be 1. Otherwise, it will be 0. And then we think, oh, nothing was deleted. That fact couldn't have existed because it doesn't error on its own. So we can then do if not row count, raise HTTP exception, 404 fact not found. And then retroactively say, from a user experience perspective, we do want to let them know that the ID didn't exist. So we can do that here. So if you then come back over, and then we have our red delete fact. If we then delete fact number 1, then we get a 204 back, which I believe is 204 no content. Yeah, because we don't need to send any content back because we've just deleted the content that we would potentially want to. If we run that again, we will get an error saying, fact not found, because it tried to. It didn't error. It just returned none. And so we can retroactively raise the fact. So yeah, that's all I wanted to show in this video as a little bit of homework see if you can work out how to list all the facts. And I'll give you a hint, it's very similar to getFact. It's actually even simpler than getFact. So see if you can list all the facts stored within the database. And if you really want to, you can add an edit as well. A little bit of a thing for that. It would be either app.put or app.patch, depending on what you wanted to do. This is part of the reason why I didn't really want to talk about it, because there are two different things for edit. But I'm going to leave that as homework for you. If people really want me to talk about it, I will make another video about it. But for now, I just wanted to keep things really simple so you sort of understood what was going on within FastAPI, how the status codes work, how the response models work. And yeah, this response model is actually responsible, if I go back here, for what have I done? I'm not sure what I've done here actually. Oh, there we go. I'll just click that. For rendering all of this. So in these examples here, you have your responses, and this is this. Let me know in the comments what you plan to build using FastAPI. I want to know what sort of things people are getting up to. I want to say a massive thank you to all my members and patrons on screen now, especially Mazada Roshaman III for being so generous. If you want to know 5 ways to optimize your Python code, then make sure to check out last week's video. But I'll see you in the next one where we do whatever we do next.